Another sort of situation that happens quite frequently, and this is one that I've actually on some, some side engagements and working with some friends and some colleagues at other companies that I see over and over again. And so what happens is SQL Server is designed to load compiled code into cache and to keep it there as resident in the cache as long as it can, because the CPU is expensive, and we want to be able to avoid having to go through those really expensive process of compiling and optimizing the code each time. So that's what we want to achieve. So typically what is going to happen is we're going to execute, using sp exec, execute SQL rather, or the exec command. We're going to execute a piece of SQL or transact SQL code. It could be a function or a stored procedure or just a plain old batch. SQL Server will check to see if it is in memory. If it is already existing in the plan cache, that's the part of memory set aside for execution plans, it's already in there, so let's go ahead and execute it. If it's not in the plan cache, then we need to read that from the system tables that keep all the definitions of the different batches and so forth, if it's a stored procedure or a function. If it's, let's say a batch or something like that, then we don't have to do that. Then we're going to compile it, we're going to optimize it, and then finally we're going to execute it. The problem, though, is that there are things that we do to our code, either intentionally or unintentionally, that cause SQL Server to come back and say, well, yeah, it's in memory, yeah, I've executed it, but now what I need to do is I need to recompile that. And so it's going to execute it, get part of the way through executing, and for various reasons it will see that it has a problem and it has to go and rebuild that code so that it can fully process whatever it is that you've requested. Now, that's good a lot of the time. You'll see Aaron and I build into our examples in particular, you'll see that with recompile option over here. Or perhaps you'll see someone even have some preventative maintenance to recompile a specific object. And when you expect it to do that, that's great. So you can create your procedures with the recompile option. You can execute them with the recompile option. You can even, for specific SQL statements, like a select statement, you can have with option recompile right there on it. And you know that the plan that exists in cache is going to be thrown out and a new one created for it. The SP recompile option is a little different. What you do there is you name a base object like a table, and then any other objects that depend on that table are recompiled the next time they're invoked. So a stored procedure or maybe a view that will get recompiled. Another set of reasons why execution plans aren't going to be in cache is because they were aged out of memory using the LRU-K algorithm that the SQL Server relational engine uses to age unused or lesser used execution plans out of the cache. That's okay. That's normal. That's natural. It happens moment by moment. There's a process called the lazy writer that cleans up aging and unused plans out of cache. But what we want to tell you about today are those unexpected situations that cause your store procedures and transact SQL batches to recompile. And the two main ones are if we have interleaved DDL and DML, or if we have big changes in the schema definitions, the metadata that is, since the last time it was executed. So let's dive in a little bit more on that. Now, I'm not actually going to go into deep examples here. I'll just give you a kind of a conceptual sort of example. Now, just in case you're unfamiliar with the acronyms of DDL and DML, these are old-fashioned ANSI standard acronyms. DDL stands for the Data Dictionary Language, and that's the create, alter, and drop commands. So, create table, alter table, drop table would be one example. And DML statements are the data manipulation language statements. So that's select, insert, update, delete, and merge. So if any of those are executed, that would be called a DML operation. So what happens in SQL Server, and just as a side note, this is very much worse in the older versions of SQL Server and is gradually improved all the way up to the current release of SQL Server. However, it's still a problem. So even in its, with the best and latest algorithms inside the relational engine, this will still cause recompiles. It's just that SQL Server is a lot smarter about how it handles that in, say, SQL Server 2012. So one of the examples that I like to give, I had a buddy who was one of the lead architects and product managers at a medical ISV, an independent software vendor and independent software provider, I guess ISP. And so they made software for medical practices, and they were having problems with one very specific set of customers. They had two sizes of customers: a regular sized doctor's practice, which was about 3 to 5 doctors in a partnership. Everything worked great for them. So whenever they sold their software to that kind of practice, it was very good performance. On the other hand, they did have a few customers that were like the Mayo Clinic or Loma Linda or Vanderbilt University in size, huge, hundreds of doctors working there, thousands of patients a month. And I should, just as an aside, mention that anytime you have a software provider telling you, you are our biggest customer ever, run. That's going to be a scary situation, because you're going to push the limit for what they are aware that their software can scale to. And in their case, what was happening was they couldn't figure out why performance was so bad in those big environments. And what was going on was they had a number of processes that were automated or were built into their code in which a stored procedure would be called, and it would create a temporary table. Create table pound test DML. That's a DDL statement. And then they would say something like, insert into test DML, select star from another table, or select some specific columns from another table, like we have here. So now we have interleaved the DML with the DDL. In SQL Server 2005, a little bit less so in 2008, that means this whole thing's going to have to recompile once here. Then there'll be some more DML code, maybe something like an alter statement to change some values and to update some null columns in there. Now we're going to alter that table and add another column to that table. And then we're going to do another update statement. And then we're going to insert some more values into a different table. And again, we've interleaved the DDL and the DML again. And so each time this happens, for SQL Server 2005 in particular, a little bit less so in 2008, SQL Server will have to recompile each time there's an interleave. So each time we go through, it's going to recompile 6, 7, 8, 12 times in a piece of code like this. In 2008 R2, and even more so in 2012, it's smarter about this. So what it'll do is, rather than recompile all the code each time, it'll pick up where it left off. So when it does that first recompile, instead of looking at the first code and working its way back down through the code, it'll pick up at, say, the alter table statement where it left off. And so we have less total number of recompiles for a given stored procedure like this than we would if we were on an older version. Now, having said all of that, what do you think? Can you think of a solution or two, Aaron, that we might apply to try and make this less problematic?
Sure, there are a couple of things that you could do. One would be to move all of the DDL together. So if you do the create and the alter before you start inserting any data. The other would be to just create the temporary table with whatever you're doing the alter, with that stuff in line. So if you're adding a column, just create the table with that column in the first place. And an obvious one would be to get rid of the temp table altogether, and then you don't have to worry about it. But I understand that in some cases temp tables can be quite useful in helping simplify the different parts of a query or a stored procedure. So.
Yeah, absolutely. Great point. Why? And why they had these alter table statements in here actually is just reflective of the way in which they wrote their code. So when they first wrote their code, the first developer went in and created the table and did some work. And then later on, a month later, another developer said, oh, I can reuse the stored procedure to do exactly what I want. I just need a little bit more in that table. So let me add more to that table. And like you were saying, they didn't have a kind of a top-down approach to the code. They just kind of had an additive approach. And in fact, if we just kind of rebuilt it from the ground up and said, hey, let's get rid of all these extra statements to add 1 or 2 columns and just create it as it needs to be in its final form at the very start, there you go. You've reduced the number of interleaves of the DDL and DML, and so you have less of those recompiles. Just like what you were saying, actually in our case, I asked my friend what's going on. I said, how many of your stored procedures work this way? And we took a look, and it was well over 400. Yeah, so it was one of those
someone
things.
Someone took one pattern once and just copied and pasted it into every single module.
That's exactly right. They had one of their lead developers wasn't truly a SQL person. They were, ASP.NET or C# person, and so they said, okay, I got this to work in SQL. I'm not really familiar or comfortable with it, so I'll just keep reusing that. Some other things that we did as well, just like you suggested. In a lot of cases, it was these stored procedures were being used for ETL processes, to move data from one place to another. And we realized, well, heck, we're using the same sort of tables over and over again to move data. So why don't you just make those permanent tables? In fact, let's make them permanent tables and index them for optimal speed and throughput. Some other things you can do here that will alleviate this problem significantly is, where appropriate, you could use a table variable rather than a temporary table. So table variables do have the advantage of avoiding these recompile problems. They have other downfalls, I guess you could say, other downsides. In fact, we should probably talk about this in one of our future webcasts, Aaron.
Yeah, that's a good idea.
Okay. But yeah, so you could certainly use table variables. And then another thing I've seen some other customers do, besides kind of aggregating all your like code together, so you could have all your DML at the top and DDL at the bottom, or vice versa. You could also just call subordinate stored procedures. So you could have another stored procedure to do the insert operations. So you could exec insert to my test DML table, and then select from my test DML table, and so forth. And because that one calling stored procedure never interleaves DDL and DML, even though it makes calls out to other stored procedures that do that, it will execute fine without any of those excessive recompiles.
Right. It's a property of the module, not of the logic.
Exactly. Yep. Now, another thing that can cause recompiles, it's worth noting, is if we made big changes to the underlying schema or metadata that are referenced in, say, a stored procedure. So if, while I'm executing a stored procedure, it's a big one, and somebody makes a change to one of the base tables, they add some columns, they take them away, they add some constraints, like a primary key or a unique constraint or a check constraint, or they take those away, or they make a big data type change. Then that will definitely have an impact. And also if maybe a stored procedure or a view or something like that, between invocations, one of the indexes in there that is normally used is dropped, then it won't be able to use the existing plan, of course. It'll have to recompile and create a whole new plan.
And in a lot of those cases, you want to recompile. Right?
Yeah.
You want to get a new plan, unless you have cases where the changes that you're making to the schema have absolutely nothing to do with the query. But in most cases, you'll want that. And you'll also find that you won't necessarily get that if SQL Server doesn't know that a query depends on that object. So if you have dynamic SQL in a stored procedure, it's not necessarily going to make that connection that, hey, this stored procedure needs to be recompiled because the table that you mentioned in here has changed. You might be passing the table name in as a parameter. So there's no way for SQL Server to know that stored procedure could potentially touch that table. So just something to be, another one of those little things about dynamic SQL that you need to be aware of.
In fact, one of the big, and this is, again, just a little sidebar, but one of the big boogeyman of the SQL Server world is something that we're touching on kind of obliquely here, but it's related, and it's something called deferred name resolution. And so what that means is SQL Server doesn't check. It doesn't check certain kinds of for the existence of certain kinds of objects at the time that you create a stored procedure. The thought being, well, you might have created it as a temporary object in a calling stored procedure or something like that. So it will let you compile different kinds of stored procedures and so forth, different kinds of code, without that object actually being present and available to the block of SQL code. And so when it's executed, not when it's compiled, but when it's executed, it will fail. So kind of related to that, to this idea of underlying changes, things like that can happen. And then the objects that depend on them will fail at the time that they're executed rather than at the time that you make the changes.
Right, and that's a bad time for things to fail. Right?
That's right.
SQL Server is doing you a favor, sort of, by giving you the benefit of the doubt that you're creating a stored procedure that references a table, but that you'll create this table before you actually execute the stored procedure. That doesn't always happen. And Erland actually has a connect item. If you search for set strict checks on, he wants an option in SQL Server that would be very strict about this and would not allow deferred name resolution. And unless you have a case where you have foreign keys that are pointing to each other, so you have a circular reference, so you can't create one table without the other, and vice versa. I'm all for that. I think that's a great idea, and to be able to set that option can prevent a lot of these runtime errors that happen because someone typed out a table that didn't exist yet, or would never exist, right? But SQL Server lets you create it anyway. So.
Yeah, tricky stuff. Another related point is that whenever the index statistics get updated inside a SQL Server, and there's a number of conditions in which the statistics can get updated, then SQL Server will do us a favor. This is a good thing. It will recompile those stored procedures to take advantage of the new statistics out there. That is great because the fresher the statistics, the better the plan it can come up with, and we always want good plans. Now, there are situations where you might want to more vigorously control that. So there are some, I believe they're database level settings. Does that sound right, Aaron? For the auto update statistics?
Yes.
Yeah. So you could turn those on or off if you wanted to, but our recommendation would be to always leave on the auto update statistics and auto create statistics options. You can manually run a update statistics command yourself if you need to refresh those on a more regular basis.
So you can set those as long as you're not using SharePoint. I believe SharePoint, you violate support by turning those on. And there are certain settings at the server level that SharePoint will block install if the settings are on. So you can change them after the fact, but you can't have them in the bad setting in SharePoint's terms, which is the good setting in almost everybody else's world. It won't let you install it until you have that setting the way that SharePoint wants it.
Ironic.
A couple of the other products that Microsoft does do similar things.
Wow.
So fun stuff.
Yeah, that's crazy. A question I get a lot after I'm presenting at a big event like TechEd or PASS or something like that is, it goes like this. I've been running SQL Server for a year and a half now, and when we first ran it, it was very, very fast. In fact, it was really fast maybe the first year, and then it slowly has gotten slower and slower and slower over time. And I'll usually ask, is this a product that or application that your team wrote themselves, or is it a purchase product? And usually the answer I get back is, this is something we bought, maybe even bought in a turnkey. Here's the whole server with the SQL Server and the application installed on it. And what we find a lot of times is that either they've turned off auto update stats and auto create stats, or the vendor who made that software wasn't aware of the default behavior of auto update statistics. So one thing to keep in mind is that auto update statistics, that sounds great. Sounds like it's automatically going to take care of you. There's a little asterisk at the end of that sentence because the data in the various tables and indexes and whatnot, they have to change at least 20% before it will kick off the auto update statistics routine. So if you have a table with 10 million records, that means you got to have 2 million records that have changed, either inserted, updated, or deleted since the last statistics refresh before anything's going to happen. That could be months or years, depending on how busy your application is.
Yeah, and as the table gets... Oh, go ahead, sorry.
Oh, go on.
I was just going to say, as the table gets bigger and bigger, you're compounding things. So the table is getting bigger. The number of data pages you have to read to run a query gets bigger. And auto statistics updates are even less likely to occur because the table is bigger. So you're completely compounding that problem, and it just it's going to be like a hockey stick at some point where it's just going to be out of control.
Right. There is in 2012 of SQL Server, I believe there's a new trace flag that will adjust that that value. So if you set the trace flag, it will adjust the value that auto update statistics kicks off based on a couple of other elements, like how much memory there is, and if there's a lot of memory available, then let's go ahead and do it more frequently than at a 20% percentage. And that, I believe Jonathan Cahias wrote a blog post about that.
I think he did, and I have a few details to share. So it's trace flag 2371, and it's actually in SQL Server 2012 and SQL Server 2014 and SQL Server 2008 R2 SP1 and above. So the trace flag is available to some 2008 R2 users as long as you're not on RTM. Now, one thing that it still doesn't affect is filtered indexes and filtered statistics. So the real problem there is when you have a filtered index that represents 1% of your table, and you're relying on 20% of the entire table to update, not 20% of the filtered index. So you're going to have a lot of cases where if you've created a filtered index specifically to highlight and make available a very small percentage of your table, those statistics are never going to update on their own, even with this trace flag set. It's just never going to happen. So I think that they are planning some fixes for that in 2014. And I also heard rumors that we would be able to update statistics on a partition level. So instead of updating stats across an entire partition table, you could focus on the active partition, for example.
Right. Yeah, that's cool.